Let's look at an example spectrum. I'm not actually going to draw the spectrum out to start with. I'm just going to draw the molecule, and we're going to identify what we would expect to see for this particular molecule. We're going to start off with the simple molecule known as acetophenone. And I'm actually going to draw out all of the hydrogens as well. And so if we look at this molecule, we see several different types of functional groups. And so what I always like to do when I'm trying to predict what an IR spectrum would look like, I draw everything out, and then I simply identify the functional groups. Okay, so for the functional groups for this molecule, of course, we got a carbon-oxygen double bond, and that's for a ketone. We've got the ketone here, that's a CO. And if we look in our table, what we recognize is that's going to appear somewhere between 1680 and 1750 reciprocal centimeters. We also have carbon-carbon double bonds as part of the benzene ring, and we're going to see those in the IR spectrum as well. And those appear around 1620 to 1680. So they're going to be a little closer towards that fingerprint region than the ketone overall. We also notice that we've got carbon-hydrogen bonds, but we've got two flavors. We've got a carbon-hydrogen bond that's bound to an sp2 carbon. So we're going to draw that out as sp2 carbon H. And that's, if we look in our table, it's going to appear somewhere around 3020 to 3080. And we also notice that we've got sp3 carbon hydrogens. So we're going to just draw a CH there to represent that. And if we look in our table, we recognize that those actually appear somewhere around 2850 to 2960. Okay. And so what we would expect to see then in a spectrum, again starting at 1500, going up here to 4000, we would expect to see something at about 1680, and that should be quite strong. You can see something at around 1680. For the ketone, you're going to see something at around 1620 to 1680. It's not going to be quite as strong. Of course, there's some fingerprint region stuff out here that we're not interested in, so we're going to cut that off. We're only interested in the functional groups. So we're going to see two stretches in the 15 to 2000 range. Call that 2000. 1500. So there we've got those stretches. We're not going to have anything between 2000 and 2500 because we have absolutely nothing in this molecule that is sp hybridized, so we'll just see a straight line kind of go through there. And then when we get into the hydrogen region, we expect to see two different flavors of hydrogen. And the first one that we're going to come to is the CH. We're going to see a CH stretch, and these are usually medium to weak. And then as we get closer to 4000, we're going to see one that's probably going to be a little more intense just because there's more hydrogens here, but not much. It's going to be somewhere in the 3020 to 3080 range. And this is kind of what we would expect to see then for an IR spectrum for this molecule, which is known as acetophenone. Now, there's one important thing that I need to point out. Notice, again, we've got these two different flavors of CHs. And what you need to know is that they appear in this order. CHs in sp3 are going to appear at lower wave numbers than sp2 hydrogens. They're going to appear lower than sp hydrogen. So this is the order. CHs less than sp2 CHs less than sp CHs. And the reason is the sp3 CH bond is a little weaker and doesn't require as much energy to actually cause that stretch as it does for an sp2, because this bond is a little stronger, so it needs a little more energy. And this bond is a little stronger, so it too needs more energy, and so it'll be closer to 4000. And so Today in lab, when you get in lab, your TA is going to teach you how to actually prepare samples for IR spectroscopy. He or she's going to go over real quick, recapping some of these, and you're going to get in teams and actually run a series of IR spectra and then figure out what compound you have based on functional group analysis. So good luck and